Hey guys, welcome to Crown Smart. Today we'll be dealing with cofinite topology. So here says show that this tau is a topology on X where tau is the collection of A such that A is equal to the empty set or A complement is finite. Now to show that tau is a topology on X, we must show that it satisfies three axioms, and one of the axioms is to show that the empty set and the whole set are in what? In tau. So proof, we want to show that the empty set and the whole set are in tau. Now we know that the empty set is in tau since A is equal to what? The empty set. And this is true because tau is the collection of A and A is the open set. So for A to be an open set, A must either be empty or its complement is what? Finite. And here we know that A is an open set and A is the empty set. So this means that the empty set is in what? In tau. Now also we want to show that the whole set is in tau. Now X is in tau since X complement is empty and empty set is what? And the empty set is what? Finite. And the empty set is a finite set. Okay, the empty set is what? A finite set. So we have shown that for X to be an open set in tau, its complement is what? Finite. So therefore X is in what? In tau. Now the next one is to show that the arbitrary union of open sets in tau is in tau. So we now say take any collection of open sets, that is collection of A alpha such that alpha is in delta, and that delta is the index set where A alpha is in what? Tau. Okay, for alpha in delta. Now we have that for all alpha in delta. Now we have that since A alpha is in delta, now if A alpha is in delta, then this means that A alpha, so A alpha is in tau, then this means that A alpha is either empty or its complement is what? Is finite. It's just from our assumption here that if A alpha is in tau, then it means that A alpha is either empty or its complement is what? Finite. But our target here is to show that the arbitrary union of this A alpha is in what? In tau. So from here now, you can say, okay, the union of A alpha, as alpha comes from index, is equal to the union of the empty sets. And we know that the union of empty set is still the what? Empty set. And the empty set already we know is in what? Is in tau. Therefore, the union of this is in what? In tau. But we are not yet done with the conclusion. We also have to show that the union of this is also in tau, where the A complement is what? Finite. So now when I say, okay, the union of A alpha, also let's say the complement of the union of A alpha, where alpha comes from index, is the same thing as using your De Morgan's rule. This will give you the intersection of the complement of A alpha, okay, where alpha is in index. Okay, so your De Morgan's rule said that this is equal to this. You can verify it. Okay, now we know that a complement here, we know that a complement is finite, right? Since a alpha is in the topology. Since a alpha is in the topology, a complement here is what? Finite. But the intersection of this a complement is also what? Finite. So this means that everything here is what? Finite. So the complement of this union is what? Finite. Therefore, this union is in what? The topology. Because we say for anything to be finite, for an open set to be in the topology, its complement must be what? Finite. So this is an open set where its complement is what? Finite. Therefore, the union of a alpha in index is in the what? The topology. Okay, now we also want to show that the finite intersection of this collection in the topology is finite intersection of open set in this topology is also in the topology. Now we also have 3. Okay, so we say take any finite collection. This is a finite collection. AI, this is a finite collection. I equal to 1 to n, where AI is in the topology. Now we know that if AI is in this topology, then it means that AI is empty, or AI complement is what? Finite. So we are going to take this separately. So we are going to do and our target is to show that the finite intersection of this is what? Is in the topology. So to find the finite intersection of this, the first thing we are going to do is do the intersection of this part. So we are going to have I want to have this as the intersection. We have the finite intersection I equal to 1 to n of AI is equal to the intersection of the empty set. And we know the intersection of the empty set is always the empty set. So this means that, and we know that the empty set is in the topology. So this means that this is also in the what? Topology. Therefore, we cannot just conclude, although we will not conclude it yet, we just say n, the intersection of AI I equal to 1 to n is in the what? Topology. Okay, that's for the empty part. Now we want to show where its complement also is the finite intersection of this is also in the topology, using the other case where we have let's say the complement of the finite intersection of AI I equal to 1 to n. Okay, first of all, we did the intersection. When AI is equal to the empty set, we did the intersection of both sides, and we discovered that it's still the empty set. So therefore this is in the topology. We also want to show that if we do it with the complement, can it also be in the what? Topology, before we can now conclude that the finite intersection of this is in the topology. Now we have this as the complement of this finite intersection, and using your De Morgan's rule, this is the union of I equal to 1 to n of the complement of what? AI. Now this is De Morgan's rule. Okay, now we know that AI is in the topology, right? And since AI is in the topology, this means that its complement is what? Finite. Now the union of finite sets, if the finite union of this set will also give us a what? A finite set, meaning that the whole thing here, the whole set here is what? Finite. So this means that the complement of this finite intersection is what? Finite. Hence, okay, therefore the intersection of AI I equal 1 to n is what? Is in the topology. Hence, tau is a topology on X. So therefore, a cofinite topology is a topological space. And this is the end of our proof. Please, I hope you like the video, and please don't forget to subscribe to our YouTube page at Crown Smart. Please subscribe. Thank you very much.